Hello everyone, welcome to Physics online classes for class 11 students. Let us continue chapter 4 Motion in a Plane. Today we are going to study about applications of relative velocity. As we have studied in the previous class what is relative velocity, and also we derived an expression for magnitude and direction of relative velocity. Now let us study the applications of relative velocity. Yes, we already know that relative velocity is velocity of one body with respect to another moving body. That gives relative velocity. For your syllabus, you are going to study three applications of relative velocity, and they are relative velocity of rain with respect to man. The second application is to cross the river in the shortest path, and the third application is to cross the river in the shortest time. So these are the three applications of relative velocity. Now we can study one by one in detail. The first application is relative velocity of rain with respect to man. Observe here, in the first application we are going to find relative velocity of rain with respect to man. Here, how to solve the rain-man problems. Now you can imagine, let us consider a situation where a man is standing on the ground and he is experiencing a rainfall. The man is holding an umbrella to get safe from the rainfall. So here we are going to find relative velocity of rain with respect to man. Observe here, when a man is standing on the ground, the rainfall takes place in the vertically downward direction. Is it clear? The rainfall takes place vertically in the downward direction. Suppose if this is a ground, let us imagine this is a ground. A man is standing here. So that rainfall takes place vertically in the downward direction. In this direction, rainfall takes place. So what he is doing now? Now this man, he is going to hold an umbrella just not to get wet from this rain. So he is holding an umbrella. When a man is standing simply on the ground, so he can hold the umbrella vertically upward direction because the rain is in the vertically downward direction, so he will be safe from the rain. But now what happens? If the man is moving or if a man is walking, in which direction the man has to hold the umbrella? That is the question. How to hold the umbrella when the man is walking in the rainfall? So this is a situation we are going to consider here. Let us find relative velocity of rain with respect to man. Observe this diagram here. Let us consider the rain takes place vertically in the downward direction. Let us consider XY frame here to understand relative velocity, or we can consider the directions. Here we can consider this is east and this is west. This will be north and this is south. So here in this direction the rain takes place. Let us consider a man is walking towards east direction. In this direction the man is walking. When the man is walking towards east direction, here the rainfall takes place in the downward direction. Along south direction the rainfall takes place. Now I am going to consider velocity of the man is taken as Vm. Velocity of the rain is taken as Vr. What is Vm here? Vm indicates velocity of man. Vr indicates velocity of rain. Rain takes place in downward direction. The man is walking towards right side or towards the east direction. Vm and Vr, or we can take Vm is equal to V1 and Vr equal to V2. V1 is velocity of man and V2 is velocity of rain. What we have to find here? We are going to find velocity of rain with respect to man. Velocity of rain with respect to man. That means I can write here Vrm. What is Vrm? Velocity of rain with respect to man is equal to Here we already studied what is relative velocity. Relative velocity is velocity of one body with respect to moving body. VRM, velocity of rain with respect to velocity of man. So here we can write the equation VR minus VM. In the previous class we already studied VAB is equal to VA minus VB. So in this way we can write VRM equal to VR minus VM. VR indicates velocity of rain, minus of VM indicates velocity of man. VR minus VM. So this indicates a subtraction of two vectors that we have studied. VR minus VM. VR, this is plus VR, this is minus VM. Minus VM means here we have to consider minus VM. VR minus VM. So here we can consider according to law of parallelogram, the resultant vector is along the diagonal of the parallelogram. Here I am going to consider resultant vector, that is VRM. So why we have to consider in this direction? Because this is minus Vm. Observe this equation. Vr minus Vm. Vr is here along S, means southward. Minus Vm, it is along west direction. So here we have to consider resultant vector along the diagonal, that is VRM. VRM equal to VR minus VM, or we can consider V equal to, we can take it as V2 minus V1. So this gives relative velocity of rain with respect to man. Observe this diagram here. The first picture you can observe. Let us consider a man. The man is walking towards the east and this man is having velocity V1. Let the rain be falling vertically downward with velocity V2. To find a relative velocity of V indicates relative velocity here. This is relative velocity of V of rain with respect to man. That impresses the velocity minus V1, because we know that V equal to V2 minus V1. Minus V1 means we can take along minus x-axis. So V gives relative velocity. Now here alpha, you can observe the angle alpha. Alpha is made by V with vertical direction. Alpha is angle between resultant velocity and the velocity of the rain. That is vertical direction V2 and the resultant velocity V, that gives alpha. Now I am going to find magnitude of resultant velocity as well as its direction. Expression for magnitude of resultant velocity. Magnitude of resultant velocity. Let us find the magnitude value. So from the diagram you can observe here, from the diagram I am going to write the resultant velocity is denoted by V. V equal to, I am going to join from this value. You can observe this dotted line. Let us join these lines here, south and this is west. So V equal to, we can use the Pythagoras theorem. V equal to, we can take V1 plus V2. V square equal to, I can write minus of V1 square. Minus V1, this is minus V1 and this is V2. So according to Pythagoras theorem, V equal to minus V1 square plus V2 square. Or we can write it as minus V1 square will be minus, means it will become plus by squaring. V1 square plus V2 square. We want only its magnitude. So we can write V equal to square root of V1 square plus V2 square. So this gives magnitude of resultant velocity. What is the magnitude value? V equal to square root of V1 square plus V2 square. Now similarly I am going to find the direction. Expression for direction of resultant velocity. How to find its direction? Here you can observe the angle alpha. So from the diagram I am going to write the value of tan alpha. Can you tell me what is the value of tan alpha from the diagram? From the diagram, I am going to consider tan alpha is equal to, observe this diagram here, this is alpha. Tan alpha equal to opposite side divided by adjacent side. This is opposite side, this is adjacent side, and this is hypotenuse. Opposite side is minus V1, adjacent side is V2. So here tan alpha equal to opposite side divided by adjacent side. Opposite side value is how much? V1 divided by adjacent side is V2. So tan alpha equal to V1 by V2, or we want alpha value, alpha equal to tan inverse of V1 divided by V2. So this gives direction of resultant velocity. So magnitude is V equal to square root of V1 square plus V2 square, and its direction is alpha equal to tan inverse of V1 over V2. Now what it indicates? See here, the man must hold his umbrella in the direction of relative velocity of rain with respect to man to protect himself from the rain. See here, when the man is simply standing on the ground, he can hold the umbrella in the vertically upward direction. In this direction, he can hold the umbrella. But when the man is walking, then he has to hold his umbrella at the angle alpha. In this direction, he has to hold his umbrella to protect from the rain. With how much angle he has to hold the umbrella? With angle alpha, he can hold his umbrella to protect from the rain. Observe this picture here.
How to solve rain-man problem. Let's analyze the situation where a man on ground experiences rainfall. Say if the man is holding an umbrella and rain starts falling from the vertical direction. Certainly, his umbrella will save the man from getting wet. But what will happen if the man starts walking? To answer this correctly, we need to find the velocity of rainfall with respect to man. The velocity of raindrops with respect to man, Vrm, is given by the relation velocity of rain, Vr, minus velocity of man, Vm. Let's consider this xy frame of reference. Since the rain is falling in vertically downward in y direction, let's say Vr vector. And man is moving towards the right along x direction with velocity Vm. So minus Vm vector would be in minus x direction. Resultant of the two vectors will be in the direction of the velocity of raindrops with respect to man. This means that the man will observe that the rain is falling at an angle theta from the vertical, where tan theta can be calculated as the ratio of magnitude Vm and Vr. So while walking, if man is holding the umbrella in vertical direction and raindrops are hitting at an angle theta with the vertical direction, then obviously the man will get wet. So in order to save himself from getting wet, he has to hold the umbrella in the direction of raindrops with respect to man. All of us hold our umbrellas similarly at an angle to avoid getting wet intuitively without caring about the physics behind this.
Yes. So we have to hold the umbrella with respect to the angle alpha to protect from the rain. So this is all about the first application, that is relative velocity of rain with respect to man. Now we can study similarly the second application, and that is to cross the river in the shortest path. Here again you can observe, let us imagine this is the direction of the flow of river. The river is flowing from left to right direction. Now the swimmer, he wants to cross the river with the shortest path. We know that the shortest path is from A to B. A to B is the shortest distance to cross from the one end to another end of the river. The river is flowing from left to right, but the swimmer he wants to cross the river in the shortest path. So how to find relative velocity? See here, let the river is flowing from left to right. It is desired that The swimmer must swim perpendicular to the direction of flow of river. So this is the direction of flow of river. So perpendicular to this direction, the swimmer has to swim to cross the river in the shortest path. The perpendicular distance between the two sides of a river is the shortest path. Which is the shortest path here? The perpendicular distance between two sides of the river is the shortest path. Which is the shortest path here? The perpendicular distance between two sides of the river is the shortest path. The river flow that carries a swimmer in the downstream. What happens here? This A to B, this is the shortest path. Now the swimmer is swimming along A to B. But the river is flowing from left to right, so that the flow of river that carries the swimmer in the downstream means when he travel from A to B, he will not reach the point B. Instead of B, he is moving in this direction. So why he is moving in this direction? Because of the river flow. That river flow carries that swimmer in the downstream as he crosses the river. Therefore, the swimmer must swim in the upstream. Instead of here, he has to swim in the upstream direction so that he will come to point B. Is it clear? Shortest distance is A to B. That is the perpendicular distance between two sides of the river. But the river is flowing from left to right. So that's why when the person is swimming from A to B, he is gone moving in the downstream. His direction changes because of the flow of the river. That flow of the river carries him towards the D direction. He will reach at point D instead of B. It will be the longest path, but we want the shortest path. That's why what we can do here, the swimmer has to swim in the upstream direction. From A to C he has to swim, but because of the river flow, he will reach the point B. This is the shortest path to cross the river. Now you can observe this diagram. In this diagram, V1 and V2 that indicates velocity of swimmer and river. V1 is velocity of swimmer, or you can take a boat, swimmer, or you can take a boat. And V2 is velocity of the river. Velocity of the river is V2 and velocity of the swimmer is V. Here, observe this diagram. So the resultant velocity is what? V. So we can take V is resultant velocity. What is V here? Resultant velocity. Resultant velocity means what? Velocity of a swimmer with respect to river. What is resultant velocity? Resultant velocity means relative velocity, that is velocity of swimmer with respect to river. Velocity of swimmer with respect to river is denoted by V. Then D is width of the river. Width of the river is denoted by D. And let us take T is the time taken to cross the river. Time taken to cross the river is how much? T here. Right? Now we can find easily magnitude and directions of resultant velocity. Observe this picture here. A, B, C, this is a triangle. Here AB is resultant velocity. AC, this is velocity of the swimmer. And C to B, that is velocity of the river. Now I am going to find an expression for magnitude. Magnitude of what? Magnitude of resultant velocity. What is resultant velocity here? Resultant velocity means velocity of a swimmer with respect to the river. So now from the diagram I am going to write. You can observe we want resultant velocity. So this is a triangle ABC. We can consider Pythagoras theorem. V1 square is equal to, from the diagram I am going to write. We can use Pythagoras theorem here. So from the diagram, V1 square equal to what? V square plus V2 square. V1 square equal to V square plus V2 square. But we want resultant velocity V. So this equation can be written as V square equal to V1 square minus V2 square. Or we want the value of V equal to, we can write square root of V1 square minus V2 square. So this gives magnitude of resultant velocity. Is it clear? Let us take it as equation 1. What is the magnitude of resultant velocity? V equal to square root of V1 square minus V2 square. Similarly, I am going to find the direction of resultant velocity. Yes, how to find the direction of resultant velocity? Observe again the same diagram. This is alpha. Alpha is angle between resultant velocity and the vertical vector, that is V and V1. So we can take the trigonometric function. Suitable function is sine alpha. See here, alpha is here. This is opposite side. This is hypotenuse and this is adjacent side. Sin theta equal to opposite side divided by hypotenuse. So substitute their value. Opposite side is V2 and hypotenuse is V1. Sin alpha equal to V2 divided by V1, or alpha equal to sin inverse of V2 divided by V1. Let us take it as equation number 2, and this equation gives direction of resultant velocity. What is the direction of resultant velocity? Alpha equal to sin inverse of V2 divided by V1. Now similarly we can find the expression for time taken to cross the river. How much time is taken to cross the river? Let us find its time here. Yes, we know that simply the definition of velocity we can use here. Velocity is a rate of change of displacement s divided by t, right? Rate of change of displacement. We want time here. T equal to this equation can be written as s divided by v. S indicates width of the river divided by v indicates velocity of swimmer with respect to river. Velocity of swimmer with respect to river. Substitute the value. Width of the river is denoted by d. Observe here, d is width of the river. D divided by velocity of swimmer with respect to river. We just found the equation, that is v equal to square root of v1 square minus v2 square. Substitute here, square root of v1 square minus v2 square. So t equal to d divided by square root of v1 square minus v2 square. So this gives time taken by the swimmer to cross the river. Let us take it as equation 3. Is it clear? Equation 3 gives time taken to cross the river. Equation 2 gives direction of resultant velocity. Equation 1 gives magnitude of resultant velocity. So this is all about the second application, and that is to cross the river in the shortest path. Remember, when you want to cross the river in the shortest path, observe if the river is flowing from left to right, then you have to swim in the upstream. If you want to swim in the downstream, that will be the longest path. So this is all about the first two applications of relative velocity, and the third application that we can study in the next session.